All right, so this is going to be a lesson over biconditionals. Okay, a biconditional is a statement created from two conditional statements. Okay, so the two criteria are going to be P then Q must be true, so that's the original conditional, and Q then P must be true, so that's that converse. Okay, so if both the statement and its converse are true, then we can write the statement as a biconditional. To do this, we must put the hypothesis and the conclusion together using the words if and only if. So it's no longer going to be an if-then statement. We're going to get rid of the if, and where that then is, we're going to replace it with that phrase if and only if. All right, so we have some examples down below. So given the statement, identify the hypothesis and the conclusion. All even numbers are divisible by 2. Okay, so our P, remember that is our hypothesis, is going to be the even numbers. And the Q, our conclusion, is that they are divisible by 2. Okay, so now that we have that, we are going to write the conditional statement. So remember, that's that if-then statement. So if it is an even number, then the number is divisible by 2. Okay, is the statement true or false? So if it is an even number, is it always going to be divisible by 2? Yes, that is a true statement. Okay, so now we know the first part is true. We need to then determine, is the converse going to be true before we can write the biconditional? So we're going to write that converse statement. So remember, that's just where we're going to switch the P and the Q. So if a number is divisible by 2, then it is even. Okay, so we then, like I said, need to determine, is the converse true or false? This, once again, is a true statement. Okay, so the last part for this example is, if they are both true, then we can write a biconditional with P, if and only if, then Q. Okay, so then we have that symbolic form written out there for you to see. So here I'm going to write the biconditional. We have a number is even if and only if the number is divisible by 2. Okay, so now we've got 3 more examples or problems. So for these 3, we are going to check if both the conditional and its converse are true. And if they are, then we're going to write the biconditional. Okay, so just for the sake of kind of making sure we understand why, if it is not both true, then I'm going to just write which one of them isn't true to kind of help you identify why we are unable to write the biconditional. Okay, so for number 1, we have if you live in Texas, then you live in the United States. Okay, so that is a true statement. Now we got to think about that converse. So remember that converse, we're going to switch places. So if you live in the United States, then you live in Texas. Okay, I know we've seen that example. I think it was in the last lesson where we did determine that was a false statement. So because you live in the United States, you don't always live in Texas is not a true statement. We're going to say that we have no biconditional converse is false. Okay, so moving on to number 2, we have if today is Monday, then tomorrow is Tuesday. Okay, so that is a true statement. Now let's think about our converse. If tomorrow is Tuesday, then today is Monday. Well, that is also going to be a true statement. So since we have the conditional and the converse are both true, we're going to go ahead and write that biconditional statement. So today is Monday if and only if tomorrow is Tuesday. Okay, and then we've got our last one here. If a truck weighs 2 tons, then it weighs 4,000 pounds. Okay, so for those of you that aren't aware, yes, that is a true statement. Now let's think about that converse. Converse, we're going to switch the order. So if it weighs 4,000 pounds, then the truck weighs 2 tons. Okay, so that is also a true statement. So I'm going to go ahead and write my biconditional. We have a truck, weighs 2 tons if and only if it weighs 4,000 pounds. Okay, so that is it for that section. Let's look down here. So if you remember in the last lesson, I did mention that we do have some other terms we tend to use for if and then to help us determine what's my hypothesis, what is my conclusion. And so this section is giving us the list that you will want to know to make sure that you are able to identify that hypothesis and conclusion correctly. I would highly suggest making flashcards to help you with that, especially for those of you that do not have a good memory. Okay. All right, so now moving into our last section here, okay, that's going to be our tough case, okay? So our tough cases, a lot of the times those are when you have sentences that start with no, and we're going to say no P is Q, and we'll see an example down below in a second. And the way you are going to actually translate this sentence to make it make sense is you are going to say if P. Okay, so it's no longer no P. It's going to be if it is P, then it's not Q. Okay, so that's what our tough case is going to look like. So the example down below, just for you to see, is going to be the original sentence stated, no dogs are cats. Okay, so the if-then form would be if an animal is a dog, then it is not a cat. Okay, so like I said, that no dogs, that hypothesis there, is going to actually going to change into if it is a dog. And then my conclusion, that Q, it being a cat, is going to say, then it's not a cat. Okay, so we want to watch out for these. They will cause you some trouble. All right, well, that is the end of our lesson over biconditionals. Hopefully this is helpful, and I'll see you next time.